Equivalent expressions, part 1. I can write equivalent expressions. Algebraic expressions that simplify to an equal value are equivalent expressions. So this is an example of an equivalent expression where if I simplified this, 3x plus 5x or 3x plus 2x equals 5x. So 5x does equal 5x. Like terms. Two or more terms that have the same variable raised to the same power. The coefficients of like terms can be different. The variable has to be the same. So for instance, there's an x and an x. So I can put those together by combining them, and that would give me 5x. Okay, these are algebra tiles off to the right. We're going to use these to answer the question. So we're going to write an addition expression that highlights the different tiles in each model. So I have an x squared, and I'll just cross that off, plus an x squared. So I used both of those, plus an x, 3 of those, right? And then I can go cross those off so I know I used them. And then plus 1, plus 1, plus 1, plus 1. So now I need to go combine any like terms. So when we put like terms together, we just learned that they have to be the same variable and the same power. So if I look over here in the algebra tiles, the x squared terms look alike. And as I can see right here, x squared plus x squared looks alike as well. Same variable and same exponent. So that would make 2x squared. And then if I look over to the algebra tiles once again, I have 3 of these x's. So the x's are like terms as well. So plus 3x. And then the numbers out here all by themselves as well look the same, so plus 4. So now I'm going to write an equivalent expression for these expressions. And that means I'm going to go combine like terms. So I have to determine what's alike. So the first thing I see is a number, and then I need to look and say, are there any other constants or numbers by themselves? And there's one right here. Now, this is important. The sign in front of the number goes with the number. So this is a negative 3 over here. So I have 7 minus 3. So I do 7 minus 3, and that is 4. Now I need to look at and see if there are any other like terms. In here, I have a variable with x, y together and x, y together. So I can put those together. So I can say 2xy plus 5xy. And when I put those together, that equals 7xy. 5x squared plus 3x minus x squared. So, like terms, do I have any x squared terms? Yes, I do, and it's a minus x squared or a negative x squared. So I will take 5x squared minus x squared. Now, I have to remember there's not a coefficient in front of this x squared term, but there's always an unwritten 1 if you ever see that. So I do 5 minus 1, which is 4x squared. And then the only term left is this 3x. I can't put that with anything else, so I just bring it down because there are no other like terms. Okay, we worked on distributive property. So do you remember distributive property where we could take A times the quantity B plus C, and that would equal AB plus AC. So this is what it looks like with algebra tiles. So we see the 3 over here to the left, and we are multiplying, which is what that symbol is, the x plus the y. So if I take 3 times x, I get 1, 2, and 3 x's. If I take 3 times the y, I get 1, 2, and 3 y's. That is the same thing that happens down here with variables. Some of you liked what I called the rainbow method that we used, where I have to multiply the 3 times every term inside the parentheses. So I take the 3 times x and get 3x, and then 3 times y and get 3y. Write an equivalent expression for 5 times the quantity 6x plus 3. So I'm going to take 5 times the 6x and then 5 times the 3. So 5 times 6x, I take the coefficients and I multiply them. 5 times 6, and there's only one x when I do that, plus, because of the plus sign there, and because this will be positive because there's a plus sign here, 5 times 3, which is 15. These two expressions are equivalent, equal. So 3 times the quantity x plus 4y, I am going to multiply 3 times the x and then 3 times the 4y. So 3 times x is 3x plus, because of the plus sign here, and it will be positive because of the plus sign, 3 times the 4y, 3 times 4 is 12, and I have 1y with that. So factoring expressions, we're going to write equivalent expression by factoring, and if we remember, that means we're taking something out of it. So in other words, we're dividing both terms by it, and we're going to put it back into the distributive property. And when we did this before, we did this by finding the greatest common factor. So the greatest common factor of 3x minus 6 between 3 and 6 is going to be 3, because I can divide both of them by 3. So I can write this actually as a fraction or division problem, where I'm taking the 3x minus 6 and dividing both of them by 3, or pulling the 3 out. When I do that, I can actually separate these. Put the 3 out front, because that's my GCF. 3x divided by 3, well, the 3 over 3 just equals 1. So that leaves me with x minus 6 divided by 3, which is 2. So the equivalent expression by factoring would be 3 times the quantity x minus 2. Now the question is, can we take it back? So we have to be, if they're equivalent, we have to be able to take it back. So I can multiply the 3 times the x and 3 times the negative 2. I get 3x, 3 times negative 2, minus 6. These are equivalent. So that means this is just in a different form from this. 32 plus 8y. So we're going to look at the coefficients once again, or the constant, and say, what's my GCF? What can I divide both of these by? And I can divide them evenly, both by 8. So if I pull the 8 out and put it in front, I say, well, 8 times what equals 32? And 8 times 4 equals 32. And then 8 times what equals 8y. And 8 times y equals 8y. Let's double check that and make sure it goes back. So we have 32 plus 8y. Okay, your turn. You try it.